IT infrastructure and networks. So we've seen a lot of business-facing applications. Here's a bit the contrary. We're going to look behind everything, and we're going to start with clients and servers. So no, this is not in a restaurant. In the client-server model, the server provides processing power as well as storage to different client devices. So let's just, simplify this a bit. Think of a large mainframe computer. That's to say a very, very large computer with a lot of processing power that is not going to have simply one screen. It's going to work for many different screens. That could be the case, but it's more often many different other laptops, computers, or other devices. When you are working in a modern organization, you're going to have servers that are going to provide, say, storage where you can put things on the storage from your laptop to, protect them so that they're better backed up. When you have large organizations, you also have large applications. And these applications, won't run off someone's computer or on a number of computers and then send things to each other. No, they're usually going to work off a large server with an enormous amount of processing power so that, very complex operations can be done quickly on these massive computers, and then the data simply sent to terminals, or more likely laptop computers. Networks. Networks consist of infrastructure. This includes cables, wireless connections that are needed to kind of set up the client-server model. So it's the different interconnections between them. A virtual private network. Now this allows encrypted communications to a user, and that means that if you, say, are home working, a popular thing right now, you would not simply send data which can be intercepted and read by any malicious actor. Rather, you'd send it through a virtual private network in an encrypted fashion. With different encryption keys, you would have a file sent from one place, which, if intercepted, could not be read, received by a second person, who's the final user, and with a certain encryption key, open it up. An intranet site. Now, you probably know about intranet sites, since you can go to your own company's intranet site and get certain shared services. Maybe you have some nice little photos from the last company excursion, and you probably have some nice welcomes and greetings from your HR department. But it can also allow, obviously, a lot of different services, including shared applications, including information about the different parts, about different news in the organization. A gateway enables different and dissimilar networks to communicate. Okay, I want you to understand this a bit. Say you have an intranet, but to be able to get to, say, a part of the organization that was, say, purchased from a different company, mergers and acquisitions, but they have something that is slightly different. They have an infrastructure which is not fully compatible. Between that kind of infrastructure and the one that you have, you might need a gateway between them for them to properly communicate. A router, so we've seen this slightly before during firewalls, they route, if you understand that word, they channel communications to a certain point, usually a centralized point, and then distribute it to other points in or outside of an organization. So they channel communications to help better security. We saw that for the firewall part. Everything is routed to a central location, passes through a firewall, and then goes out. And it helps in the efficiency of communications. You have fewer I'll call them bilateral connections, between Bob and Mary's computer. You wouldn't have a direct connection. Rather, you'd have a connection from Bob to the router, from the router to Mary. And mainframe computers, massive computers with enormous amount of processing power that can be used as servers, that can help in applications, and that are often connected to many different peripherals.